Hello everyone, today we're going to be talking about Integrated Math 2, Practice 1. We're talking about quadratics and the key characteristics. First question under the classwork says, quadratics produce curved graphs known as parabolas. To the side you can sketch a couple of pics. They can be opening upwards, look something like that, or downwards, like this. You can recognize a quadratic equation whenever you see an x squared. So if you're looking at the equation, you're always looking for x to the second power. So something simple like y equals x squared is an example. They can be more complicated. Y equals 3x squared plus 2x minus 9, for example. Two versions of the quadratic function are standard form and vertex form. Standard form looks like this. I'm going to use function notation this time. F of x instead of y equals ax squared plus bx plus c. Vertex form, f of x equals a parentheses x minus h squared plus k. Describe the following with vocabulary, with words, pictures, or examples. The a value. The a value is important. The first letter in standard form or here in vertex form. If that number that is sitting there happens to be a positive number, we know that the parabola is opening upwards. If it is a negative number, we know that the parabola is opening downwards. The axis of symmetry is an imaginary vertical line that would cut that parabola into perfect halves. The maximum or the minimum, it can only have one or the other. If it's an upward opening parabola, it has a minimum or a bottom point. If it is a downward parabola, it has a maximum or a highest point. The vertex of a parabola is this one specific point either here or here that indicates where the parabola changes direction. So in this one you'd be going down until you got to the vertex, and then you would start coming up. In this one you'd be going up till you got to the vertex, then you would start coming down. X-intercepts, zeros, roots. All three of those mean the same thing. They're just asking where does it hit the x-axis. Sometimes you can have two x-intercepts, like this one. Sometimes you might have just one x-intercept, where the vertex lands right on the x-axis. Sometimes you can have no x-intercepts at all. Doesn't touch the x-axis. Y-intercept, where does it hit the y-axis? Every parabola will have one y-intercept. At some point in time, somewhere, it will hit the y-axis. Backhand side where the homework begins, I've given out 6 different parabolas, and I just want you to fill in this chart for each one. Number 1, this parabola, the a value would have to be positive. The reason it's positive is because this parabola is opening upwards. The axis of symmetry for this parabola, the imaginary vertical line that would cut it in half, would be right here. And if you happen to notice, this is 0, 0 on the coordinate plane, so that line would be going right through negative 1, 0, and we can say x equals negative 1. Does this one have a maximum or a minimum? It has a minimum. A horizontal line right here indicates that it will go no lower than this. Nothing in the parabola is down here. We indicate that with a y. This has a minimum. I'm going to circle that. Of y equals, and then I just look to the y-axis to see where that is. It's located right at negative 4 is what that says. Its vertex is a combination of those two things. That point right there, the vertex, is located at negative 1, negative 4. Notice that's both the axis of symmetry and the minimum maximum value put together. This one has two x-intercepts. Hits the x-axis there, and it hits the x-axis there. This point is negative 3, 0. This point is positive 1, 0. Its y-intercept, as best we can tell, it's somewhere right here between -2 and -4 on the y-axis. We're going to call that -3, which means this is 0, -3. Does this parabola have an a value that's positive or negative? Because it's opening downward, this one would be negative. Its axis of symmetry would be here, and that's located where x is +1. Does it have a max or a min? Well, since this one's opening downward, this one has a maximum or a high point. That's as high as that parabola goes. So it has a max, and that's located at y equals, that line is at y equals 2. Put these two numbers together, you also have its vertex, that point. That's located at 1, 2. Has two x-intercepts, here and here. That's the point -1, 0. That's the point 3, 0. Its y-intercept is located here. It's between 1 and 2, so we're going to say that's 0 and about 1.5. Third parabola has to be a positive a value because it's opening upward. Its axis of symmetry, if I were to draw that, would be located here. That's at the place where x is +1. This is an upward opening parabola, so it has a minimum. That minimum, if you can see on the y-axis, is -4. So we're going to say a min of y equals -4. Put these two together, we have the vertex. 1, -4 is the exact address of its vertex. This has two x-intercepts. Hits the x-axis here, hits the x-axis there. That point is -1, 0. This point is +3, 0. It has a y-intercept located about right here, and that looks to be the point 0, -3. Down to the bottom three, opening upwards, it's a positive a value. Axis of symmetry. Its axis of symmetry is actually the same thing as the y-axis this time, which means x equals 0. Right? It's not to the right or to the left anywhere on the x-axis. It's right down the middle where 0 is, so x is 0. Does this have a max or a min? This has a min because it's opening upward forever, so there's no max, but it does have a lowest point, and that lands right on the x-axis, so that means y equals 0 here. That's as low as it will go. It doesn't go down to any of the negatives on the y-axis. It's above all that. Put those two together, you find out that the vertex, this point, is located at the origin, 0, 0. Because it lands on the x-axis there, it has one x-intercept, also at 0, 0, and it has one y-intercept, also at 0, 0. Number 5, opening downward, its a value would have to be negative. Axis of symmetry, vertical line that would cut it in half would look like that. That's located where x is +2. Because it opens downward, it has a maximum, not a minimum, but a maximum height. Located, if you can look at that carefully, it's actually 16. Y equals 16 is as high as that goes. Put these two together, you have its vertex, 2, 16. 2, 16 is exactly where that point would be, its highest point. Two x-intercepts here and here. The one to the left is -2, 0. The one to the right is 6, 0. And its y-intercept is located here. That is the point 0, 12. Finally, we have number 6. It is an upward opening parabola, so it has a positive a value. Axis of symmetry here would cut it in half. That's located where x equals 1. This guy is an upward opening parabola, so he also has a minimum value. It goes as low as where y is +2. Put those two together. 1, 2 is also where the vertex is. And notice that this one does not have any x-intercepts. This is the x-axis and this one is above it. We were talking about that earlier, which means that there are none. There are no spots where that parabola hits the x-axis. But it does have a y-intercept that is located right here. That is somewhere between 2 and 3. So I'm going to say that's like 0 and about 2.5. Alright, catch you next time.